What is the acceleration of block and trolley system in figure? Coefficient of kinetic friction between the trolley and the surface is 0.04. The pulley and the strings are assumed to be massless. First, let us consider the 20 kg mass. The forces acting are mg is acting downwards. It is balanced by normal reaction R. As there is no motion in the vertical direction, we can write R is equal to mg. The system has a net acceleration towards right. So T and Fk are not balanced. So we can write for 20 kg, T minus Fk is the force for acceleration, that is m into a, or 20 into a. So for 20 kg, T minus Fk is equal to 20 into a. Next, the frictional force Fk is equal to mu k into r. R is equal to mg. So substitute mg instead of r. Mu k is 0.04. Mass is 20 and g is 10. So we get Fk is equal to 8 Newton. Here the second mass 3 kg, its weight mg, that is 3g is acting downwards and tension T is acting upwards. System has a net acceleration downwards. So we can write 3g minus T is the force for acceleration. So the equation for the second mass is 3g minus T is equal to 3a. Now let us add equation 1 and 3, that is equation for 20 kg and 3 kg. The first equation is from equation number 1, T minus Fs is equal to 20a. From equation 3, 3g minus T is equal to 3a. On adding, we can cancel T and minus T. We have 3g minus Fs is equal to 20a plus 3a, that is 23a. We have Fs is equal to 8 Newton. So substitute 8 Newton here. The value of g is 10. So instead of g, we can put 10. 3 into 10 is 30. 30 minus 8 is 22. So we get 22 is equal to 23a, or a is equal to 22 by 23, that's 0.96 meter per second square. This is the acceleration of the system. Now let us consider a second method to solve the problem. First, let us consider the opposing force that opposes the motion of the block and trolley system downwards. This is the kinetic frictional force Fk. Its value is mu k into r. R is equal to mg. And substituting the values, mu k is 0.04, m is 20, and g is 10. So we get the opposing force at 8 Newton. The driving force is the mass of 3 kg downwards. So driving force is equal to mg. Mass is 3 and g is 10. We get 30 Newton. Now let us calculate net force. Net force is F driving minus F opposing. That is 30 minus 8. That is 22 Newton. The equation for acceleration of the system is equal to net force by net mass. Net force, here we have 22 Newton. The net mass is 20 plus 3, that is 23. So we get the answer as 0.96 meter per second square. This is the second method to solve the problem. Here we have another problem. A system of masses m1, m2, m3 are connected by a string. m1 and m2 are on a rough table. The coefficient of static friction mu s of the table is equal to mu. The downward acceleration we have to find out. m1 equal to m2 equal to m3 equal to m. So we can use the equation used in the previous question to solve the problem. The driving force or F driving is the mass of m3 which is acting downwards. So driving force is equal to m3g, that is m into m3 is equal to m into g. Opposing force is the frictional force that acts on m1 and m2. Since they are having the same masses, we can write 2 times Fs. Fs is equal to mu s into mg. Now net force is equal to F driving minus F opposing. F driving is mg and F opposing is 2 mu s mg. On taking mg outwards, we get net force is equal to 1 minus 2 mu into mg. The value of mu s is given as mu. So substitute mu here. So this is the net force. Now net mass is equal to m1 plus m2 plus m3. Three are having the same mass. So substitute m for the 3 masses. We get 3m. Acceleration A is equal to net force by net mass. Net force or F net is equal to 1 minus 2 mu into mg, and net mass is 3m. On calculating, we can cancel mass from the numerator and denominator. We get an answer as 1 minus 2 mu into g by 3.